Good day, ladies and gentlemen. So our first speaker, Mr. Vasilii Ermilov, is going to talk about exploiting dynamic renderers for server takeover and profit.
Everybody, thanks for joining today, and thanks for letting me present my talk called Exploiting Dynamic Renderers for Server Takeover and Profit. Let me double check that the recording is going on. Yep, it is. So thanks again, and let's start. So before we dive deep, I'll do a quick explanation of what we're going to talk about today. Dynamic rendering. I'll explain to you what it is, but as a quick overview, it's a technique that is used for serving pre-rendered websites to different bots and crawlers like search engines, etc. There are two most popular solutions for this purpose. We're gonna try to hack them, because if such applications are not properly configured, they may introduce vulnerabilities to a network or to the infrastructure. So yeah, this is the main purpose of this talk. A little bit about me. My name is Vasilii Ermilov. I work as a security researcher at RCES. Here's my Twitter account and a web page where you can find other social links, media, if you want to reach out. Speaking of my company, it is called RCES, and it is a San Francisco-based startup which focuses mainly on static analysis and improving software security and reliability. Also, the outline of this talk is that, first of all, I'm gonna give you like a background for my research and the motivation that I had, and an explanation of what is actually dynamic rendering. Also, I would like to dive a little deeper into the architecture of this type of applications and how they work. Finally, explain how to hack them, and provide also some tips and tricks that may be necessarily like the exploits, but maybe like ideas that may be useful for hackers. So let's start. The main purpose of my original research was headless browser server-side request forgery, which is quite a well-known vulnerability, and a lot of bug hunters, researchers already discovered it. It's already, you can find a lot of content on it, but my purpose was to find such vulnerabilities in the open source software and open source packages. And as you see in this picture, I believe there is no need to go deeper into this. What is the headless browser SSRF like? Let's say you have a website that utilizes headless browser for some feature, like maybe it generates some picture, an avatar, or maybe a template for something, and it requests, as part of it requests something from, let's say, picturehosting.com, like in this picture. And if an attacker can craft some malicious request and force this headless browser to request what was not intended to be requested, usually it is local infrastructure endpoints, there is a possibility to perform an SSRF and do whatever, take over the server, perform RCE, stuff like that. So that's and as I already said, the exploitation, the vulnerability here is quite clear, and usually while doing research you want to find something that is something new, like a new vulnerability or new technique, but in my case I actually wanted to do vice versa. I clearly understood the exploit and what the vulnerability is. I wanted to find different ways how the malicious user input can get into the headless browsers, and that is why I had to understand what these headless browsers utilized for. So, and as I mentioned earlier, I work at a company that focuses on static analysis tools, in particular the SAMGRAP. It's developed in R2C. It's an open source product that is used for static analysis, and my plan was to use it to scan and find as much as I can the situations where developers let some user input to sync into the headless browser. Like, for example, I was covering with the static analysis rules such a library called Puppeteer. I believe it's the most popular nowadays among developers, wrapper for headless browsers. It's written in Node.js, and that was my main focus of my work for a certain amount of time. I was gathering all the packages that use Puppeteer and was trying to find how they use it. And you can find the rules that I used in this link at the end of the page of this slide, and play with those rules if you want to repeat my research. Maybe you'll find something more interesting. So going on, this Puppeteer research actually led me to such understanding that I didn't have before, that actually time changed a little bit. Well, that's my opinion and things that I was thinking of. Maybe you already know all of that. Sorry if it is so, but I had kind of an outdated information. I thought that headless browsers are used for testing mostly, and sometimes people use it for generating pictures and PDFs, and I thought that it's kind of an anti-pattern, that it's not how it should be used really in production. But give me a second, sorry. But actually nowadays, and here is on this slide, if you don't see clearly the text, no worries. It's just I'm trying to show you this. On the first picture, there is one of the first initial commits to Puppeteer, where in the README the testing environment is written as the #1 use case. The use cases for Puppeteer is testing environment. And if you look at the GitHub page of Puppeteer right now, testing is somewhere in the end, and main use cases are generating screenshots and such thing as crawling SPAs, generating pre-rendered content, aka SSR or server-side rendering. And going on a little bit further, dynamic rendering is some sort of this thing over server-side rendering. It's one of the options for doing that. And I bumped into this while doing this research. As I already mentioned, I thought that it's something that is not really you want to see in production or try to avoid, but actually it's not like that. Developers use and utilize headless browsers a lot for a multitude of different features and different things nowadays. That's why I believe it's important to understand what can go wrong, what can be done from attacker's perspective with that. And that's how I bumped into the dynamic rendering, because I was stumbling upon packages that are intended for this feature more and more, and I get curious, and that's how we have this talk. So let's dive deeper. What is dynamic rendering actually? As it's mentioned on one of the Google websites, dynamic rendering is a workaround that is used for serving pre-rendered website pages to the crawlers, like Google search engine, Slack bot, whatever other bot, Twitter bot, you name it. Me personally, I wouldn't call a mature technology workaround, but anyway, it's, well, as I already mentioned, it's widely used. So what actually it is used for? It's mainly it's embraced and proposed to be used for webmasters, web designers, or SEO specialists, because the idea is to improve search engine optimization of a website. Usually the website that has a lot of JavaScript on the page, and needless to say that it's heavily utilized by applications that have modern JS frameworks like React, Angular, etc. So And I think it is better to show it how it works and then like explain it in, with the words because it will be easier to understand. So let me open the browser. Okay, Google has this testing website, or I should say showcasing website that they created for demonstrating polymer technology that they have, and they also use dynamic rendering as part of like this demonstration. So this is like testing, I would say, like fake website by Google. And if you look at the page source here, it's just a long and huge, like, sorry if you see, if you don't see it, it actually doesn't really matter, but the idea is that it's a huge chunk of JavaScript that just loads on the page and generates all the content in the user's browser. That's the idea. And let's see what's gonna happen if we request this website pretending to be a crawler or a Slack bot to be particular. So let's go. Where is it? So I'm requesting the very same website. We have the very same, it's just prettified a little bit, the huge chunk of JS. But let's change the user agent and pretend to be, let's say, a Slack bot. Okay, so now we have, this is the Slack bot's standard user agent. After sending the request to this endpoint, what we receive is totally different content. Well, actually, for the user or for the bot, the content will be the same, but the thing is that the code is totally different. Now it is a lot of CSS, a lot of HTML. Well, no need to like understand the whole code here. The idea behind that is that what happened is that the request went to headless browser, it loaded this page and returned us the static version of it. So like it's like the same page, but it's static, and all the JS from this page is stripped, and this is the form in which it returned to the crawler of the bot, so that the bot can scan it without bothering with like JS and understand what's happening on this page. These bots, crawlers work. This is like the main idea of this feature of this type of application, like to serve the static content instead of the dynamic one. This is also a way to identify those applications, so identify websites that use dynamic rendering. You just send requests pretending to be like a Google Chrome and pretending to be, like in my case, Slackbot, and compare the difference. Usually it's it's evident, like you can easily understand that this page is like a bunch of JS, and this is definitely a static content, because it usually it's relatively bigger, not just like a few bytes. It's like a huge difference in terms of the size and in terms of like what you get. So also apart from the user agent header that is like mostly used for identifying those techniques, also some dynamic render applications, they allow to send, instead of a header, allow to send this URL parameter, the specific parameter that will turn the dynamic rendering on. And it's also very useful for exploits and for identification. Either I'll try to show you it a little bit later. Let's move on. So, as I already mentioned, there are a few most popular applications, open source applications for this feature, for this matter. One of them is the RenderTron. It is created by Google, and Google's, well, fair to admit that I wasn't able to find any Google website that would use this technology, but they actively embrace webmasters and SEO specialists to use it on their websites, saying like that, this technology is totally fine with our search engine, so you'll be fine, you'll improve your SEO, etc. So it's quite popular. And next popular solution is PRenderer. It's actually a software as a service, so you can, like, no hassle involved. You can just pay them money and they will do all this pre-rendering work for you. Or also they like open source their product and you can use it on your own server. And there is a pre-render and fork by Netlify, which is pretty the same, and I should admit that all of these applications are pretty the same in terms of the architecture. But speaking of this Netlify version, comparing to the others, it looks like this one is the most secure by default one. If you run it just on the spot, it without any involvement in any configuration stuff, it works. It just does not allow any malicious stuff without specifically configuring it. So that seems to be the most secure in my opinion, but also the least used in the wild. Also, a few flicks from different docs and websites, as I already mentioned. Netlify uses this technology, and also they have this pre-rendering feature for users, like people who host their website there. They can turn on the pre-rendering thing, and also there is like a flick from some Algolia software that allows, embraces dynamic rendering as a solution for their users if they want to improve, as already mentioned, the SEO of the websites that use this Algolia thing. So and this pictures here is just to show that this is seems to be used in the internet. So companies and websites use this feature. So that's why let's think about architecture of dynamic rendering application so that we can understand how to hack it. The architecture, well, first of all the applications mentioned above behave relatively the same, and not much difference in terms of their behavior and in terms of their architecture. So I'll mainly focus on RenderTron by Google during this talk, but the same stuff apply to other solutions as well. So let's understand the architecture. So from a user perspective, it's quite simple. You, the user or website, you load this website in your browser like you requested. You get the initial HTML and JavaScript back. That's it. If you are the crawler, or if you pretend to be a crawler or a bot, here's what happens. Server, sometimes a server, sometimes some middleware, or whether it's like a software, piece of software on the server or something else, understands that this is a crawler. The main algorithm here is, as we already seen, to get the user agent and to check if it's a user agent of a bot or a crawler, and if so, the request is passed to the rendering application. And in turn, the rendering application now requests, opens a headless browser and requests the original website and get what the user would get, the initial HTML and JavaScript. Then it all renders in the headless browser, and the result of this rendering is stripped and processed a little bit, like the JavaScript is extracted from the page, and we get the static HTML that looks like let's say like it's gives the same result as if you loaded the dynamic page, but it's like all the static HTML that is can be easily digested and processed by the crawler. It returns back to the requester, to original requester, whether it's like a crawler or a fake crawler. Nevertheless, that's pretty much it, how it works. What can go wrong? Certain situations in this architecture that can introduce vulnerabilities. I highlighted them. So the first is when the request is passed from the server to the renderer. What can happen is, like, under certain circumstances, we can craft the link this way that the renderer will load not what was originally intended. This is mostly related to, well, first of all, open redirects. For example, if the web page has the open redirect, it will load a different URL in the end. Or, for example, sometimes some middlewares, they are not written correctly, and they allow, like, they when they pass URL to the renderer, they actually pass the different one. So you can play with the URL and force renderer to load something that you would want to load something malicious in our case. So another scenario, which is, I believe, more common, like more chances to exploit it, is if an attacker has a control of the page content. Best case scenario is like XSS or maybe HTML injection, and in this way the content that we control is still loaded in the headless browser. That's why we can control, like, what's happening in this browser, and can force it to, like, do requests that we want. Also, if we, like, under certain circumstances, if we control what's going on the original page, we can also control the static results, and sometimes it can, like, represent some malicious stuff, opportunities for us. I'll try to show it a little bit later. But at first, I'd like to start with the most easiest way to exploit the pre-rendering application. It's when it is publicly exposed, which is not how it should be in real life, in production, because it's like part of the infrastructure, and definitely not what you want to be available publicly. So, but it happens, and what we can do if we just came across one of these applications that are, like, in the wild, in the web. Let's do a quick demo. I have my own instance of Rendertron running. It's vulnerable. Please don't hack it. So this is how it looks like. It's the UI just for, like, testing purposes mainly, and so that we can perform our demo. But let's see, for example, what we can do with the Rendertron. Let's say I want to process the example.com here. We have two options. We can take a screenshot of the page, or render and serialize it like if it was the request, and get the response intended for the crawler or to the search engine. Doesn't matter, let's do the rendering. So the example website was rendered. Well, it's not very depicting actually here. We have like static content, Node.js. So it works. Also, no need to use UI, you can just directly access this render endpoint. sorry if it's like too small, like, but doesn't really matter for the sake of this demo. So what we're doing here is we request a website. Yeah, like it's a headless browser. We force it to request what we want. For example, my instance, and like I should mention that Rendertron, like because it's created by Googlers, they embrace it to be used on Google Cloud Platform. It happens, but of course, like they cannot force you, and there are a lot of like other cloud solutions used for it, like in real life, and that's not the only case. But for demo purposes, this particular instance that I have is running on Google Cloud. And for example, what happens if I want to request Google Cloud metadata, if I want to retrieve some secrets from it. Give me a second. Going on a little further, sorry. So I have this link of metadata Google internal link. What happens if we try to force and request it? Let's take a screenshot. It is forbidden, and I should mention that it is forbidden only for Google metadata, and if, for example, the application runs on AWS, there is no restrictions. We patched this application already, and the new version allows you to have a blacklist and whitelist and configure it in the way so that requests that like you don't want to happen, that they do not happen, but it all depends on the way the user configures it, right? So by default it protects only from Google Cloud data exfiltration, but who knows what's going to happen if it runs anywhere else. So also there were a small bug in this restriction that allowed us to still to retrieve the token, secret token, but by requesting it within iframe. Like I already gave you a peek here. If we force Rendertron to load this iframe with the very same link, let's see what happens. Like if I load it locally in my browser, nothing happens. But if we go to Rendertron, let's take a screenshot. Here we go. We have a token from the Google Cloud Platform. Like a few more manipulations, and we will have enough data to take over this instance. Which we will not do. This is not the purpose of this talk. And please, like, this is a demonstration server. It is mine, like, so that's why it's not a big deal that I show you the token. But yeah, please don't hack it. Anyway, let's go. This vulnerability was also reported to the Rendertron, and it was patched in the new version. And again, it was like the iframe trick is not working for Google Cloud, but who knows what's gonna, like, it's all up to users in terms of other platforms. Start with the slides. Okay. I believe that's it with the publicly exposed instances. Let's move on. So iframe I already showed you. And a picture of Showdown, like just to depict the fact that there are some Rendertron instances in the wild. You can see in this flick there is like DigitalOceans and many more. So they're publicly available, which is not how it should be. That's why it's not interesting. So the most interesting part is to attack a web application that uses dynamic rendering. And as you may see in this flick, there is an architecture that I already showed you with a slightly difference. It shows you that an attacker, under certain circumstances, can craft content of a website or craft a request in the way that will force headless browser to load, let's say, cloud metadata, or actually perform any other server-side request forgery just for demonstration purposes and just because like it's most common, the most impactful thing usually in terms of SSRF. But again, there is no limits. Who knows what's going on in the one particular infrastructure. And one more demo. I believe it would be much better to see instead of using words here. I prepared a demo web application. Here it is. It just returns okay, doesn't really matter. Sorry. Let's get back to architecture a little bit. As been said, an attacker can somehow play with the results of what's passing into the headless browser, and well, the most common scenario would be to find an open redirect just because it's on the page, and not only find the open redirect, also the open redirect link should be passed to the renderer. In this scenario, the renderer will load what we force it to load, and that's the most easiest one, I think, because not every company think of open redirect as a vulnerability. Also, different injections like HTML injection or XSS may do a thing. Even I believe in some cases like a self-XSS may work. And but let's demo the open redirect scenario. And I have a page with this open redirect thing. If you type URL parameter, for example, example.com that you already seen, you'll be redirected to the example domain. Let's see it once again, but in the request application. The main point here is that this demo app is utilizing dynamic rendering, and if we pretend to be a Slack bot, wait a little while. We should receive the response, it's actually a little bit delayed because it is passed to the instance of the renderer that I'm running on AWS. It loads this link and returns back the static content. It's not very interesting right now because it's just the word OK. Yeah, I hope it's gonna end soon. Alright, let's try one more time. Yeah, here we go. Sorry for the delay. So we have this content, okay, everything is okay. Now let's try in example.com. So we should receive a static content for example.com, which is also not very interesting. But anyway, as I mentioned, this particular demo application, it utilizes my own instance of Renderer, which runs on AWS. And for example, let's try to retrieve some AWS metadata for demonstration. And let's start from the browser. What happens if I type redirect? What's the AWS address? Let's say this local address that is available only inside AWS infrastructure. If you don't see the letters, don't worry. It's just the local endpoint that available on the AWS. And if I run this redirect now here, I'll be just redirected to nothing, because I don't have this endpoint locally. But if I pass this through, for some reason it doesn't work very well. Maybe my instance of AWS is running out of billing, I don't know. So here we go. We requested example.com with the pretending to be a Slack bot. So the request was sent to the pre-rendering app. We have it returned. Now everything works. Let's try to request the AWS endpoint. Well, I hope it works more quickly and we don't have to wait that long. So as you already seen, while requesting it in the browser, nothing happens. And now we should digest not the secrets in this scenario, but now we can poke the local endpoints of the AWS, which is like a typical SSRF, except that the fact that we are messing with like the front page application of a website. Here we go. Let's try once again. And while it's loading, I can also share some of my findings, because what happened, while doing this research, I decided to play a little bit with websites in the wild, and of course I took for the scope, I gathered all the publicly available bug bounty programs and just scanned all the websites that I was able to find that have like public bug bounty, and requested them pretending to be a Slack bot. So here we go. So now we have some metadata from AWS returned back. There's no point in sending more different requests and retrieving the tokens. The point here is that we can access it, and perform an SSRF. And as I started talking about the bug bounty that I was able to receive, I was doing the very same thing that I showed you in the example. It was as simple as it was. I found, I was requesting each website under a public bug bounty program that I was able to find, and the Rendertron specifically, it returns back the header here, Rendertron. This is also a way to identify it. It can be omitted, but by default it returns this header. And across all the websites that I had, the only one responded with it, and that was enough. Actually, that was enough. I immediately visited this website, and after that, my idea was to find an open redirect because it's easier, and I'll just like try to find some way to like affect the page in some way. And I was lucky. We at the company have static analysis rules to find the most common, like nothing unique, like edge cases where like window location is changed in the JS file, or like some well-known jQuery, HTML stuff, things like that. And I just used tools that we already have. You can access them in this link and check them out. Also, like within 5 minutes, I found the case in the JS code where like window location was using the URL param. So basically, I found an open redirect, and I found it pretty quickly, and it resulted in a request as simple as in this picture. Unfortunately, it was a private bug bounty, and it was like it's a public bug bounty, but they don't disclose the information about the bounties and the vulnerabilities. Unfortunately, that's why I don't have opportunity to like show you the exact application. But again, it was just one request that allowed me to retrieve tokens from Google Cloud instance that they were running, and I would like after a series of such requests, I had enough information to take over the server, and it received me a nice juicy bounty and the proof of concept that these applications are vulnerable and that they like exist in the wild. What I also wanted to mention here is that due to the concept of dynamic rendering and due to the motivation of it, that it is used mostly when heavily JS framework used, most of the vulnerabilities are also should rely there, like in the JS code. And the open redirect that I found was also like not the server side open redirect, but the client side one. So that's why those rules that we have in this link, they're like very useful, and they can like help you to find stuff like that. Just like small advice from me. That's more. But while doing this, going in the woods and trying to find a real vulnerability, I was actually prepared for a more, let's say, complicated case, because I was not expecting it to be that simple. I was expecting that at least the direct requests to the local infrastructure will be restricted, and what I wanted to perform is to exploit the screenshot functionality of Rendertron that we already seen. And in order to do that, it's kind of tricky exploit, but it's quite simple. But well, just watch my hands, watch the slides. I hope you'll get the idea. So let's say we have the website that uses Rendertron. We have found the vulnerability that allows us to inject our content or force it to load with the open redirect the link that we want to load. And using that, we also found out the local port where the Rendertron works. It's a simple SSRF stuff, not going that deep during this talk. But let's say it's running on the, we figured out that it's running on the, like in this case, 8081. It's usually, I believe it's like the default Google Cloud Platform address. Nevertheless, so we figured it out. We figured out that Rendertron locally runs here, and what we do now, we force it to load the page that doing the following. It fetches this link, and the idea here is that it fetches the link that forces Rendertron to request itself once again. That forces Rendertron to request itself once again, and which is in particular requests finally the page with the exploit. Here's how it works. The first request going on, Rendertron requested, like it's the first Rendertron instance the first tab in a headless browser, and our malicious link is passed there. Now the new tab in the headless browser is opened, and it requests RenderTron locally, which requests like the same thing happen, and in a new tab it requests RenderTron locally once again, which opens in turns the evil website that we have. And this website hosts content that forces RenderTron to load itself locally once again, but this time to send us the screenshot of the some like secret of like metadata in our case, for example, and disclose it to us. But it's not happening because we requested from our website evil.com, and we try to request some localhost 8081, and it is blocked by the same origin policy, and we cannot we can't receive this file. So, but what happened next is that this content is loaded, rendered, and passed back to the previous instance, to the previous run of the RenderTron, which is actually was happening under the localhost domain. And now we have localhost requesting localhost, and same origin policy is not the case. And now we can download the picture of the screenshot of SSRF endpoint. Sorry. And that's what I was preparing for. I was lucky to bump into some not well configured instance, and this exploit was not needed, but I want you to know about it because well, who knows, it's maybe it will bring you some bounty or like points during, I don't know, CTF, stuff like that. So let's see how it works. It's not gonna be very depicting, and because we're not gonna see the all the stuff that's going behind the curtain, but just for the sake of demonstration. So this is like a RenderTron. Let's pretend that we have a website that uses this RenderTron, and that we forced it to load the picture, or not the picture, the link that that we wanted to load. Let's go. But it doesn't matter what we hit in this situation. And this is the page that is loading in this website. It looks like this. So it's too small. It fetches RenderTron locally, as I already mentioned, and it loads the exploit page. The exploit page itself is as I already mentioned, requesting localhost RenderTron screenshot functionality, and uses JavaScript to send us pardon me, the results. And after we performed here, we can, like, the results are sent to my pardon me. So here we go. Here's the website, and that I use for request sniffing. And I got this request with the picture. It's just a base for content of this screenshot. Let's see what we have. Here we go. We have the same screenshot with the Google Cloud Platform token. Then we can now use to take over the server. So that, let's say, like, this was the most like complicated scenario that I was thinking of, and I want you to be aware of. Now, we can move on and talk a little bit about small tricks and hacks that can be also utilized. First thing, as already mentioned, rendering applications, they strip all the JS content, but they do not strip JS that is located inside of attributes. That is why if you have, for example, Open Redirect has been already demonstrated previously, you can force page that you control to be loaded. You can actually perform an XSS because the content under this Open Redirect will be sent back as a static HTML, which is actually has JavaScript in the attributes, and it will be executed, and it will be executed under the original domain of the website. And it's not very interesting because in most situations, because it requires to have crafted user agent header, and it's kind of hard to like perform and exploit in real situation. But as I mentioned in the beginning, there is also opportunity like for some renderers to pass this URL parameter instead of the user agent, and the rendering will happen. So under certain circumstances and configuration, you can send like craft a link that will like redirect to the malicious website and perform an XSS. Also, both applications, they have such functionality that if you if they see the particular HTML tags in the content, they turn it into the response headers or response status codes. Like for example, for PaRenderer, if there is meta name PaRenderer header with its value in the page, this header will be returned. This is not something like exploitable on the spot, but for example, if you have an HTML injection on the page, you can force the PaRenderer to return certain headers. I can think of, for example, course bypass or iframe include bypass, and I mean it's not like exploit as it is, but I believe it may be used in some like chain exploit chain. Is just interesting thing to be aware of. Also, like I would like to mention that DNS rebinding can be a thing here because there are multiple requests happening. Like first it is requested by like server, then it is passed to the headless browser. So I didn't play with it myself, but I believe like that something can be done with it, and DNS rebinding is definitely a thing that should be like you should be aware of, like while trying to exploit things like that. So that's it with the hacks. Trying to conclude what's been said, I want to mention that dynamic rendering is well, it allows well, if it's not properly used, it allows to attackers to perform SSRF, and SSRF, which is well not a unique situation, and it's quite well known and a lot of information about it in the internet, but the difference is that usually you have to like dive deeper, get somewhere inside the infrastructure, like play with the web application a lot, mess with it, find it somewhere like deeper into the woods. But in terms of dynamic rendering, the application is actually easily visible to the users because dynamic rendering is applied for pages that companies actually want you to see, like literally the front page. Like in my bug bounty experience, it was like literally the front page of a web application, and Also, for example, while preparing for this talk, I found out that Twitter uses dynamic rendering for their front page also. And in this scenario, like the small minor vulnerability or weakness like XSS open redirect or HTML injection may turn into something more severe and may allow, for example, to like take over the server if you're able to like retrieve some tokens and whatever else, like perform a SSRF as it is. Also, I would like to mention that these minor vulnerabilities can be easily found with static analysis, and feel free to use open source tool that we develop at my company. It's very easy to use, and we have plenty of rules that cover such topics as open redirect, XSS situations, the most common like frameworks. So I believe that's it. Thank you for watching. Yeah, thanks.